Okay, so this is just a definite integral, so we need to take the antiderivative of this, which looks like it's going to be x to the fourth minus 3x squared. There's your antiderivative. The limits of integration are 2 and 1, so I'm going to make my little parentheses. When you plug in 2, 2 to the fourth is 2, 4, 8, 16, minus whatever, 12 is 4. Minus, now plug in 1, 1 minus 3 is negative 2. So you get 4 minus negative 2 should be 6, and it is C. That's the first one. This one's quite a bit trickier. I'm actually going to use the space above it. So I'm doing number 3 right now. Okay, number 3. So here we have a definite integral, and it says, I've got a function, okay? If the definite integral from a to b of this function is a plus 2b, then what's this? I'm going to sort of show you graphically what they're talking about, okay? So we've got this function from a to b. We don't know exactly what it looks like. Maybe it looks like that. Okay. Now, the area under the curve from a to b is actually a plus 2b. What's confusing about this is this really has nothing to do with the limits of integration. That's just worth a plus 2b. Okay. So they say, well, we want the area under the curve of that same function plus 5. Okay, so what ends up happening is this function shifts up 5 units. And there are a couple different ways to attack this. This might not even be the best way, but it works. Okay, so this whole thing gets shifted up 5. So now it's up here, and they want the area under the curve. Well, let's think about what happens. What we end up with is this area a plus 2b. But we also end up with this rectangle that is 5 high now. Okay, it's 5 high. We end up with this rectangle, and then this area here, which is sort of a plus 2b. So what we end up with is a plus 2b and this rectangle. Well, what's the area of this rectangle? Let's see. The base, this distance here, is b minus a. Okay, so the base is b minus a, and the height is 5. So the area of the rectangle is really 5b minus 5a. So now the area, the definite integral we're talking about is this rectangle, which we have just shown is worth literally 5b minus 5a. And then this piece is worth a plus 2b, so we have to add that, plus a plus 2b. I'm going to go up here, and it looks like I get negative 4a plus 7b, and I really hope that's one of the answers. 7b minus 4a, there it is. That one's tricky, no doubt. Okay, 4 is much less tricky. Okay, so here's a function. We want the derivative at negative 1. So I'm just going to quickly take the derivative, negative 3x squared plus 1. Don't get mixed up. This is the same thing as x to the negative 1. So then bring the negative 1 down. So it's negative x to the negative 2. There's your derivative. I'm just going to rewrite it. Negative 3x squared plus 1 minus 1 over x squared. Okay, now, so there's our derivative right there. They want us to plug in negative 1, so that's exactly what I'm going to do. I get negative 3 plus 1 minus 1 over 1. So I'm actually going to write it out because I can't keep that in my head. So we get negative 3 plus 1 minus 1. So negative 2 minus 2, it's d. Okay, there we go.